Question 2. Two identical charged conducting spheres A and B have their centers separated by a certain distance. Charge on each sphere is Q and the force of repulsion between them is F. A third identical uncharged conducting sphere is brought in contact with sphere A first and then with B and finally removed from both. The new force of repulsion between spheres A and B is. Correct answer is option B. When two identical conducting spheres are brought into contact, charge is equally distributed between them. Now let us consider charge distribution. In conductors, charge redistributes uniformly over identical bodies when they are brought into contact, resulting in equal sharing of total charge. Initially, charge on A equals Q and on third sphere equals 0. After contact, each gets Q divided by 2. Let us examine Coulomb's law. Coulomb's law states that the electrostatic force between two-point charges is directly proportional to the product of charges and inversely proportional to the square of the distance between them. Now third sphere, Q divided by 2, is brought in contact with sphere B, Q, so total charge becomes Q plus Q divided by 2, equals 3Q divided by 2. After redistribution, charge on B equals 3Q divided by 4 and on third sphere equals 3Q divided by 4. Final charges, A equals Q divided by 2 and B equals 3Q divided by 4. Initial force F equals kq squared divided by r squared. New force F equals k, q divided by 2, 3q divided by 4, divided by r squared equals 3 divided by 8, kq squared divided by r squared. Thus, F equals 3 farad divided by 8.